Hello everyone, this is Shivam. Welcome to my channel. Today I have got another video tutorial on web-based messaging application which I have built using Python, Docker, MongoDB and Kubernetes. The application will allow users to store, view and delete messages, and it is fully deployed onto a Kubernetes cluster with the MongoDB running in its own pod. So without wasting any further time, let's look at the architecture first. So as we can see, this is the architecture of my application. So this is my Python application which I have created using Flask, and we'll be creating a Docker image out of my application, and we'll be running it onto a Kubernetes cluster. Here in my case I'm using Minikube. So I'm gonna create a pod for my application using my Python image, which I'll be creating using Docker, and then I'll be connecting this Python application to a MongoDB which will again be deployed as a separate pod in the Kubernetes cluster. And once these steps are done, we will be accessing our application via a web browser on this domain name which I have created, and we'll be accessing it via Ingress. So Ingress is another service in Kubernetes which allows our application to be exposed to outside world. We'll look each component separately into details when we are creating our application. So let's head to our editor to see what kind of application it is. Okay guys, so we are on our editor. So this is the application which I have written in Python. So let's go over this in detail. So first of all, this is a Python web application. I'm using Flask as its web container. So this statement over here creates an instance of the Flask application and specifies the folder template of storing the index.html file. So my index.html file is inside templates folders. So this connection URI is trying to establish the connection to our MongoDB database, and it is using username and password from a file which I have created here, variables.py. So what I have done here is I have encoded this username and password using base 64, and then I am storing the decoded username and password into this decoded username and decoded password, and I am passing this username and password here by referencing variables dot the username and the password. So you might be wondering why I'm looking on the other side of the camera. Actually, I have my notes open on my second monitor so that I can explain each and every details of this application in a clear and precise manner. So in this block of code, I'm creating both get and post requests. So the get request will retrieves all the messages from the messages collection and then pass it to the index.html template. Then the post request then on this line I'm trying to store the messages. So on these two lines, whenever the user submits a message, the message gets inserted into the MongoDB collection using this insert _ 1. After the messages are stored, the users are redirected to this index.html page using redirect URL. This route deletes a specific message from the database. The ID is passed in the URL as you can see here, which is used to delete a message. Once the message is deleted, the user is redirected to index.html page. One thing to note here is that this object ID refers to the ID, whatever is present in the MongoDB database. Remember, MongoDB is a NoSQL database. So for every messages, whatever we are storing in our collection, it gets assigned a specific object ID. So in order to delete it, we need to fetch that object ID so that the messages can be deleted from the table. So this is it. This is the application, and now let's head over to our Kubernetes infrastructure, which is actually the main topic for this video. So as you can see, guys, this is the MongoDB deployment .yaml file. So I'm trying to create a MongoDB deployment with the name MongoDB, and the image is Mongo:\latest, and the MongoDB container or the MongoDB pod itself will be running at 27017. This is the default port for MongoDB. So these variables are actually the credentials which will be used to log into the MongoDB database. So this variable mongo_initdb root username, I have copied this from the official Docker page for MongoDB. These environment variables are important because without them, user will not be able to log into the database and it will not work. So how we are referencing this? So we have to pass a username and password so that the user can log in. So in order to do that, I have created a secret. So as we can see here, the kind is secret, the secret name is MongoDB, and this entire infrastructure will be created under a namespace called message. So all these pods, deployment, config map, ingress, everything will be created in a separate namespace called messages. Again, the type is opaque. This is the default type, very commonly used. And this is the username and password. So again, the username and password should not be passed as plain text in secrets .yaml file. I have encoded this using base64. In order to encode any text into base64, we can simply use this technique, which is echo, and let's say our text is hello, then pipeline base64, and it will simply encode it. Now to decode our encoded value, we can just simply use -d option, and we can replace this hello with this encoded value, paste, and we can see this value got decoded. So this is about secrets. Now let's head back to our deployment file. So how secrets are referenced in a deployment file? So under environment variable, we use this format, which is value from and secret key reference, because we have created a secret. So that's why we are using secret key reference. Then the name of the secret, which is Mongo secret, as we saw here, Mongo secret, and the key name. So what key we wanted here as our username, which is username, which I have defined here in the secrets file, which is username. Again, that same thing applies for password also. Secret key ref, name is Mongo secret, and then the password is password. Now, as you can see that I have added this 3 and I have written a service below this. So this is a common practice and which is used across industry. So whenever a deployment is created, its service is also created into the same file in order to keep things clean. So this 3- specifies that this service, which is starting from line number 35, this specifies that it is a different file. So the kind is service, the service name is MongoDB service, and this is the most important thing where we connect our service to the deployment. So this selector says app MongoDB, and this matches exactly with this thing, label app equal to MongoDB. So it matches with this. Then we have ports. So our service is running on port 27017, and this target port refers to the container port on which our MongoDB pod will be running. So that's it about the service. So now let's go and apply our services and see what happens. So guys, I'm in the folder where all my files are present. But before applying our file, remember I spoke about that we will be creating this entire infrastructure into a separate namespace. So first, let's go and create that namespace. NS is a shorthand for namespace. You can type full namespace keyword, but I'm just using shorthand. It says message namespace created. Let's check it. Okay, we have our namespace created 6 seconds ago. So let's go and switch to the message namespace so that we don't have to specify the namespace in our command whenever we are trying to create any resource. So we can switch the namespace using kubectl config command. So what this command is doing, so it is setting our current context to this message namespace. So it says minikube modified. Now let's go and apply our deployment.yaml. But as we discussed earlier, that our deployment, MongoDB deployment, is referencing to a secret which is defined or which is created in MongoDB secret file. So here is a thing. So the order of execution or the order of creation of resources here is very important. So suppose if we create the MongoDB deployment before we create our secret, then our MongoDB pod will fail. So let's go and apply our secret first. Say secret created. Now let's go and apply our MongoDB deployment. It says MongoDB deployment created and MongoDB service is also created. So let's go and check. So we have a MongoDB pod which is running 13 seconds ago. Then we have MongoDB service which is of type cluster IP, and it is connected to app equal to MongoDB, which is this pod. Then we have a deployment, and then we have a replica set. So all our database resources have been created now. So we are done with the MongoDB part. So services, deployment, and secret, whatever is needed for MongoDB has been created. Now let's head to our application pod. Okay guys, so this is the pod definition file which I have created. As you can see, the kind is pod. Labels is run equal to message pod. The name of the pod is message pod, and this is the image which I'll be creating in some time for my Python application, which is this one. So this app.py, this entire repository will be converted into image. We'll take a look into that in some time. This pod will be running on port 5000. Now again, we have this environmental variable here, and you might be wondering what this is. So this is these environment variables we are using to connect this pod to our MongoDB database. So first of all, we have this mongo_host, and its value is MongoDB service. So what this MongoDB service is actually referring to? So this MongoDB service is nothing but our service name, whatever we have created for our MongoDB pod. So let's go and check that. So this is our MongoDB deployment. Let me split that. Okay, better. So as we can see here, this MongoDB service is referring to this service, whatever we have created for our MongoDB deployment. This port is referring to this port on which this service is running. This me underscore config underscore MongoDB underscore admin username and password. This environmental variable I got from the official Docker page for MongoDB. These are the credential value which will be needed for our application to log into MongoDB and store our messages. So again, we are doing the same thing. We are using the same username and same password, whatever we have defined in our MongoDB deployment.yaml file. So this is the same thing, same secret key reference, MongoDB secret password. So this environment variable, MongoDB server, is actually the database URL to which our application will be connecting, our front end application will be connecting. So in order to specify the database URL, I have created a config map. In simple words, if I put this together, then I'm trying to externalize the configuration so that whenever there is a change in database URL, you simply have to change in one location and rest everything will be taken care of. So for this, I have created a config map. As we can see here, the type is config map. The name of the config map is MongoDB config map, and the database URL is again same whatever we have created for MongoDB service. So this database URL is same as the MongoDB service name. So this is our pod. And again, I have specified the service, whatever is being connected to the pod in the same file by separating it using this 3 dash. So the kind is service, name of the service is message SVC, the service type is cluster IP, and this service is getting connected to our message pod. So this run equal to message pod specified to this label. And then the service itself is running on port 5000, and this target port, as we all know, is referring to the container port on which our front end pod will be running. So this is about pods and config maps. So now let's check our Docker file, because as we discussed, we will be creating an image for our pod for our Python application. So let's go and check our Docker file. So this is the Docker file which I have written, a very simple Docker file. It says use the base Python version, which is 3.10, Alpine 3.15. I'm creating a work directory called apps. Then I'm copying this requirement.txt to the directory. So what this requirement.txt is, so this requirement.txt contains all the dependencies which is needed by our application, and as we can see here, it also has a version for them. To generate this requirements.txt file, there is a command called pip freeze, and then redirect all your dependencies to requirements.txt. And when you press enter, this requirements.txt file will be generated, and it will have all the versions of the dependency whatever is needed for our application. Now in line 4, we are trying to install whatever dependency is there. In line 5, I'm trying to copy the source directory. As we can see here, I have a specific directory structure for my application, and all my files are present inside this source directory. Then we are exposing port 5000. As we all know that my pod will be running on port 5000, so I'm exposing that, and this is where our application will start executing. So This is the entry point, and then this is the command which I'm running, Python, and then execute app.py. So this is it. Now let's go and create our Docker image and then create a pod out of it. Okay everyone, now let's create a Docker image for our application. So in order to create the Docker image, we'll be using docker build command, which is docker build -t, and we'll give a name to the application, say msg 3.0.50, and this dot specifies that our Docker file is in the current directory, and our current directory is k8 application message application. So let's go and apply this command. Now as we can see, our Docker file build is complete. Now let's go and tag our image by using docker tag command. So what I'm doing here is I'm trying to tag this image, which is msg:3.0.50 to this repository. So this is my Docker Hub repository. It got tagged. Now let's push it to the Docker Hub. But before that, we'll have to log into Docker. So we can do it by using docker login command. It says login succeeded. Now let's push our image to Docker Hub. And it says pushed. So now we have created the Docker image of our application. Now let's copy this image name and update our pod.yaml file. Let's go to our pod.yaml and let's update it here. So we have now updated our image. Now let's go and apply this file. But again guys, our pod is referencing to the database URL which we have defined in a config map, which is a separate file. So the order of execution here is important. So let's go and apply our config map first, and then we'll be applying our pod.yaml. Okay, config map is created. Now let's apply our pod. It says pod created, service created. So let's go and check all the resources. So we can do it by using the kubectl get all, and this -o wide flag will give additional details for all our resources. So as we can see here, we have our MongoDB pod, which is running on IP this. Then we have our message pod, which is running on IP this. We have our Mongo service created, which is of type cluster IP, which is running on port 27017. Then we have our message service, which is again a type of cluster IP, and it is running on port 5000, and it is connected to the pod run equal to message pod, which is this one. And then we have our deployment and replica set for our MongoDB. So till here we have implemented most of our infrastructure. One important thing left here is to actually create a domain name for our application and expose our application to the outside world so that it can be accessed via browser. Okay guys, so this is our ingress.yaml file. As we can see, the kind is ingress. The name of the ingress is message app ingress, and it is getting created in the message namespace MSG. This is the same namespace in which we have been creating all our resources. Now, the most important part of Ingress are these rules. So these rules will define how our Ingress will behave and how our application will be exposed to the outside world. So this host is the domain name on which I am trying to expose my application. So these rules are the most important part in Ingress. So as we can see here, there is a host which is msgapp.com. So this is the URL on which our application will be accessible. And then this URL, msgapp.com, will forward the traffic to the backend, which is actually our message service. So this is the same service name, whatever we have created in our msgpod.yaml file. So let's go and check it. Let me split it to right. So as we can see here, this is our ingress and this is our pod.yaml file. Let's scroll down to our service. And we can see here this msgapp.com is forwarding the traffic to the backend service, which is msg-svc, which is referring to this service, which is connected to our pod. And the service is running on port 5000, as we can see here. So this is the most critical steps when writing an ingress. So let's apply our ingress file. It says ingress created. Let's check. So as we can see, the IP address has not been assigned yet because it takes some time for Ingress to assign an IP address, which is kind of an external IP address on which our application will be accessible. So let's give it some time so that it can assign IP address. As we can see, the IP address has been assigned, which is 162.168.49.2. Now, if we try to access our application using this URL in the browser, it won't be accessible right now. Let's check it. It says the site could not be reached. But why? Ingress actually exposed our application to outside world. So there is one small thing which we have to take care, because since it's a development environment and we are using Minikube, so we have to perform one additional step. But if this was a real environment and we were working at an enterprise level, then our application should have been accessible on this and no additional steps has to be done. So, but we are using Minikube and this is a development environment. So we'll have to map this IP address in our etc hosts file. So let's go to our etc hosts file. Now, as you can see, I have added IP address to this host name. Now let's save it. Okay. Now, hopefully our application should be accessible now. Let's check it. Our application is still not accessible. So what happened? It should have been accessible. As we can see, it says the site could not be reached. So what actually happened here? We actually missed one important thing. So since this is a Minikube cluster, so we will have to enable our Ingress controller by using command Minikube add-ons enable Ingress. Okay, I misspelled it. Add-ons enable. And we'll enable the Ingress DNS also. Now, as we can see, our Ingress DNS has been enabled and our Ingress has also been enabled. Now let's create a tunnel for our Ingress to be accessible via browser. So we'll be using the command minikube tunnel. and it says tunnel started successfully, starting tunnel on this MSG app Ingress, which is actually the name of our Ingress. So let's go and check our application. No, it says site could not be reached. So what happened here? So we enabled our Ingress add-ons. We enabled Ingress DNS add-on also. We created a tunnel. It says tunnel successfully started. What is actually happening here is it says, as we can see here, after the add-ons is enabled, please run Minikube tunnel and your Ingress resource will be available at this IP, which is 122.0.0.1. But our Ingress was assigned this IP, which is 192.168.4.8.49.2. So what is happening here is in Windows 10 and Windows 11, this is the IP address on which my system is running, and my Minikube is running on this IP, which is 192.168.49.2. Now, whenever I'm trying to access the application, I'm actually hitting this IP address, which is 122.0.0.1. And this IP address is not able to forward the request to the Ingress, whatever we have created. In order to resolve this, we'll have to map this IP address, which is 127.0.0.1, to our domain name in our hosts file. If this would have been a real cluster and a real production environment, then our application should have been accessible on the domain name and no additional steps were needed. But since this is Minikube, let's go and add this IP address to our host file. So I'm just gonna replace this with 127.0.0.1 and I'm gonna save it. So I saved it. Now let's check our application. See, our application is accessible now. Now let's test our application. I'm gonna enter some messages, which is, hi, my name is Shivam. Message got inserted. So let's enter another one. Nice to meet you. Submit. Now let's try to delete a message. Are you sure want to delete the message? Yes. Okay, the message got deleted. So our application is now running and it is accessible on our domain name, which is msgapp.com. Now let's go and check our logs for the application. Now let's check the logs for our MongoDB database. So one important thing which I would like to mention here is, you see this connection accepted. So this connection accepted is actually the IP address of our pod. So let's check the IP address of our pod. So if I do usctl get all -o get pods -o. So we can see here, this is our pod MSG app and it is running on 10.244.0.32. And this is the same IP address on which the connection was accepted. It says 10.244.0.32, which is this IP address. So our pod is connected successfully. This is another way to verify that our application is working. Now let's go and check the dashboard of the Minikube and see what resources were there. And we'll also log into our database pod and see how we can view our messages there. We can start our dashboard for Minikube by using this Minikube dashboard command. Okay, I misspelled it. BOARD. Okay, our dashboard is here. So remember, we created all our resources in the MSG namespace. So let's switch to that. And we have our deployment pod replica set. So let's head to pods, and this is our application pod and this is our database pod. So let's exec into our database pod. Mongo sh. Okay, we are logged in. Now these are some of the MongoDB commands which I'll be sharing in the GitHub link. So there are a couple of commands which we'll have to run before we can check our messages in the database. We are using the admin database, so let's authenticate to this database. It says okay. Now let's switch to our database, which is messages.db. It got switched. Now let's create a user. As we can see here, it says, hi, my name is Shivam. And let's go back to our UI. It says, hi, my name is Shivam. So we only have one message. The other message which was there, I deleted it. So let's add another message. I am a DevOps engineer. So the message is added now. Let's go back to our Kubernetes pod and see. If I do find again, I'll see here. I can see here that the message is here. I'm a DevOps engineer and hi, my name is Shivam. Let's add another message. I have over 7 years of experience. Let's check again. As we can see here, we have all the 3 messages. Let's try to delete a message. I'm a DevOps engineer. Let's delete it. Okay. Let's check the messages in the table. And we can see here, there are only 2 messages. This states that our application is fully working and our end-to-end architecture is correct. So on this dashboard, we can explore a lot of things, like we have created an ingress, we have created 2 services, then we have a config map, then we have one secret, and we have created one namespace, which is again active, and we have all our resources in this namespace. Pods, we have already looked into it. We have 2 pods. So this, we have a replica set also. So this is what the Minikube dashboard looks like, and it is showing all the resources, whatever we have created here. So I hope this video is helpful and you will be able to grab some knowledge out of it. I'll be putting my GitHub repository in the description of this video. Feel free to check it out. I'll see you in the next one. Till then, keep learning.